What is meant by resistivity? Can you tell me? What is resistance?
Oh, so sorry, I was muted. I didn't hear
Yes.
you.
What is meant by resistivity?
Uh,
Mm-hmm.
Resistivity is the result of collision between charge.
Good, good. So we are going to define resistivity, how to measure resistivity, and how to make calculations of resistance using resistivity as well. Resistance is what? Opposition to current. Anything that will slow the current down. If resistance increases, we know that current decreases.
Decreases.
Resistance is the result of collisions between charge carriers and the atoms in the current's path. This effect will vary depending on the density of the charge carriers and the density of fixed atoms as well as the strength of the forces between them. So pieces of different materials with identical dimensions will have differing resistances, and the general property of a material to resist the flow of electric current is known as resistivity, which has a symbol of rho. Got it? Resistivity
Right.
is a property for a material that can act as a resistor as well. We use this symbol to represent resistivity. Resistivity
Rho.
is a property of a material. Yeah, rho. Rho is also used for density, remember?
Yes.
Yes, it is also used for resistivity. So resistivity is a property of a material and all samples of the same material, regardless of their shape and size, will have the same resistivity, whilst their resistances may be very different. The resistance of an object is dependent on its dimensions and the material from which it is made as well. This gives rise to an equation for calculating resistance. The first equation that you remember for resistance was V over I.
Yeah.
Now the second formula for resistance is rho L over A. Resistivity multiplied by the length of the wire divided by the cross-sectional area of the wire.
But why you write two? No, power is it? Why you write on top?
Which power?
You wrote R is equal to rho power L.
No, 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 it's rho multiplied by L.
Okay.
ठीक है? See figure A, table A. What is the resistance of a piece of copper fuse wire if its diameter is 0.40 millimeter and it's 2 centimeter long? All right. So we need to find the resistance. Which wire are they talking about? Copper fuse. What
Copper,
is the resistivity of copper?
1.7 times 10 power minus 8.
ठीक है. So R is equal to 1.7 into 10 to power minus 8 multiplied by L. Length is given to us how much?
2 centimeters.
So we can write it as 2 into 10 to power minus 2 centimeters is divided by the area. Do we have the area?
Yes.
Where is it?
0.44 meters.
Is that the area? It's the
Oh
diameter.
no, that's diameter.
So wire cross-sectional area would be the area of a circle. An area of a circle is what? Pi r square or
Yes.
pi d by 2 whole square, right?
Yes.
Good. So we can calculate the area first, which is pi multiplied by, find the radius first. The radius would be half
Yes.
of the diameter. So pi into 2 into 10 to the power minus 2 square, not 4. ठीक है
Yeah.
हमने वो half कर दिया. I think you got it. Okay.
Mm-hmm.
Once you have the area, you can write down what's the area. 1.3.
2 point.
No, no, 1.3
Yes.
into 10 to the power minus 7 is the answer. No?
Yeah.
So this is how you'll calculate the resistance. Got it?
Mm-hmm. Yeah.
Good. An investigation like the one explained above produced the results shown in figure D as well. Let's look at the investigation that was carried above. We are investigating resistivity. You can investigate the resistivity for a metal in the school laboratory using a simple circuit. We will need to use a micrometer screw gauge to measure the wire's diameter, and for improved accuracy, this is done in right angled pairs at several places along the length of the wire, and then we take the mean diameter measurement. For several different lengths of the wire's resistance should be measured using the voltmeter ammeter method. The resistance will be so small, so care should be taken to ensure that all currents are safely low as well. So the equation involving resistivity means that we could calculate a value for it by rearranging the equation and taking one of the results and making the calculation as well. However, it is always more reliable to first produce a straight line graph of experimental results and then calculate our answer from the gradient as well. In this case, plotting resistance on the y-axis and x-axis would be what? Rho over A. That is how
Rho,
we can calculate the resistivity as well. And the diameter can be measured by using what? Micrometer,
uh,
screw gauge. Got it?
yes, diameter though.
Good. So if the diameter is 0.22 millimeter, that would give us an area of 3.8 into 10 power
3.8 times
minus
10
8.
power
How is
minus
the
8.
area calculated? Half of diameter first, which is 0.11 square into
Yes,
pi.
pi
That
R2.
square. Good. That has given us the area. A single 1.5 volt cell was used to drive the current, which was measured at each different length. These data were then used to calculate the resistances plot on the graph for each length. And from the graph, we can now use its gradient to find the resistivity of aluminium. Got it?
Yes.
So if you find the gradient,
But this graph show the resistivity of aluminium
how does this graph show the resistivity of aluminium? Let me show you. On the y-axis, we have resistance. On the
resistance
x-axis, we have length.
length.
We know the resistance is equal to rho L over A, right? So keeping the
Yes.
area constant, let's say, if we take area constant, resistivity would be equal to what? R divided by
R
L,
L.
right? So R is the y-axis, L is the x-axis. So the gradient of this graph will tell you what? The resistivity. Got it?
Yes.
You can take any 2 points and then you can calculate the gradient by using y2 minus y1 divided by x2
X2 over
minus
X1.
x1. So
So to
resistivity
find
for a
M.
material, the same value as the resistance between opposite face of a cubic material of the material. Clear?
But they are oppositely proportional. So the lower, or are they directly proportional?
Which one? Which two quantities?
Uh, resistance and length.
Yes, higher the length, more the resistance.
B- But if it's R over L, that means that if R is higher, then L will be
Low. No, 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 no.
oh
This
lower.
is not
Yes.
how you look at relations, man. You look at the different sides of the equal sign.
Mm-hmm.
You can't see
So
the
you need to
relation
take
between
L
R
on
and
every
L
side.
in this
Yes.
equation. R and L should be on different sides on the sign of equal
Yes.
to. If they are
Yes.
on the same side, you can never determine the relation. Never do this. Okay?
Mm-hmm.
They have to be on different sides.
Yep.
Got it? From here, we can
Yes.
see that resistance is directly proportional to resistivity and length, but it is inversely proportional to area. Got it? Lesser the area, the
Yes.
cross section wire, higher would be the resistance. What is the meaning of conduction?
What?
What is the meaning of conduction?
Conduction to you're conducting, for example, electricity.
Yeah.
Allow electrons to move between electricity to
So,
move and
how are
flow between
metals
electrons.
able to perform conduction?
Because electrons are negatively charged while
There's a sea of d
uh
electrons in metals, right?
yes,
Good.
yes, which allows them to then flow.
Good. In order to conduct electricity, solids need to have electrons that are delocalized from the solid's atom so that they can move through the solid, causing an overall movement of a charge, which is a current. The structure of metals has a regular lattice of metal atoms which are bonded together through the sharing of electrons which act as if they were associated with more than one atom. Many of the atoms also have an outer electron that is not needed for bonding between the atoms. We call these the free electrons which are surrounding these positive ions and they are always in a random motion which always change as they collide with the atoms or other electrons, but on average, the overall position of all the charge in the metal is stationary. However, if a source of EMF is connected across the metal, the electric field it sets up in the metal will push the negative electrons towards the positive end of the field. The slow overall movement of the electrons is called their drift velocity. Got it? The movement of electrons across the conductor is known as what? Drift velocity. Clear? Got it?
Oh, yes, yes, I got it.
V represented by a small v. You can see that in an electric field and a magnetic field, when electrons move, that slow movement is also known as drift velocity as well. So conduction in metal happens as the free electrons add an overall movement along the direction of the voltage across the conductor towards the positive anode due to their random collisions and vibrations. And for a metal, the random thermal motion of the free electrons will be at speeds of thousands of kilometers per second as well. But however, the drift velocity, what is the drift velocity? Speed of electrons
The
during
speed of the,
conduction.
yeah,
During conduction, the speed of electron, it is only 1 millimeters per second. But the random thermal motion of free electron might be thousands of kilometers per hour. But during drift velocity, 1
it's
millimeter per
only
second.
millimeters per second.
So the value of the electric current in a metal can be calculated from the fundamental movement of the electrons if we remember that current is equal to charge per unit time. And if we
Yes.
consider the cylinder shaded on the diagram as the length
Yeah.
of the wire that the charges move through in time t, we need to calculate how much charge flows through it in that time as well. There are n
The change
electrons
in
per
charge.
cubic meter of this metal, and the wire has a cross-sectional area as well. So their movement is at a drift velocity, and the distance this takes them along the wire, so that delta x is equal to v into t. We know that distance is equal to speed into time. So if you want to, calculate, let's take it as delta h, the change in distance is equal to the drift velocity and the change in time. It's the same thing as well. The total
Yeah.
charge will be the number of electrons multiplied by the charge on each E. That's how we find the number of electrons as well, if you remember. So the number of
Right.
electrons will be their density N multiplied by the volume of cylinder. So we have a new formula that current is equal to what? The number density of electrons into area into the drift velocity multiplied by the elementary charge. Write down this equation. N is the
I can take a
electron
picture of
density.
it. I can just take a picture of it currently and write it down later.
N is electron density. Capital A is the cross-sectional area. Small v is what? Drift
Velocity, drift
velocity.
velocity,
And E is what? 1.6 into 10 to the power minus
or
19.
minus 919.
So what is the drift velocity of the electrons in a copper wire which has a diameter of 0.22 millimeter, carries a current of zero point 0.5 ampere, number density is 8.5 into 10 to the power 28, and we have to find what the drift velocity. So if I is equal to NAVE, then V would be equal to what? Rearrange the equation. Tell me quick.
And I over Q?
What?
No, N.
You have, what is the equation above? Read it that we have made.
Uh, Change in
Read this equation that I have written over
I
here.
is equal to NAVE.
Then V would be equal to what? Rearrange the
Uh,
equation.
Drift velocity is equal to I over NAE.
Yes, good. So I over NAE. So V is equal to I is given to us, which is 0.5 divided by what is the number density given to us?
Uh, wait, 8.5 times 10 power minus,
It's 28, not minus 28.
yes, yes.
Multiplied
Then,
by area. We have to calculate area. Diameter is
so
given.
0.11 times 10 power minus 4,
Y 10 to the
which
power
is
minus
then,
4 is done over here.
yeah, which is then 3.8 times 10 power minus 88.
It's 0.22 millimeter, right? So half of it would be what? 0.11 millimeter. This is the radius, but it's millimeter. So
Yes,
I would write 0.11 into 10 to the power minus 3. Got it?
4.
Why minus
Yeah.
4? It's
It's
minus
written
3.
4.
That's 1.1 into 10 to the power minus 4. You can write it that.
Oh, yeah, sorry.
एक और decimal आ गया होगी ना, then you would write like
Yeah,
this. It's the same thing. But don't confuse yourself. Just write 0.11 into 10 to the power minus 3. ठीक है, so now you can calculate the area by pi r square, right? Pi is what?
yeah,
3.142 multiplied by 0.11 into 10 to the power minus 3
yeah,
bracket
which would
whole
be
square.
3.8 times 10 power minus 8.
Good. So this is what the area multiplied by the E.
And
E is what? 1.6
1.6 times
into.
10 power minus 19.
Good. This will give you what? The drift velocity. Clear? This formula tells us that in a cross-sectional area of a wire, there are n number of electrons per cubic meter at a cross-sectional area 10, and they are moving at a drift velocity of v. Got it?
Right.
We have seen that whilst the natural speed of electrons within a metal is very high, their progress through a metal's lattice of fixed atoms is very slow. They are constantly colliding with those atoms, making their motion like 100 steps forward and 99 steps backward as well. The natural speed of electrons is literally like 100 or thousands of kilometers per hour. But when they are passing through a conductor, a metal lattice, their speed is very slow, like 1 millimeter per hour or 1 second, because they take 100 steps forward and 99 steps back. This is known as electrical resistance. This is what we call resistance, the opposition to the electron, the opposition to the flow of electrons. And opposition to the flow of electrons is known as resistance, because higher the resistance, lesser the flow of electrons, lesser the current would pass. The frequency of collisions, it's all due to the collisions that they are colliding with the atoms as well. This is electrical resistance. The frequency of collisions is determined in part by the temperature, as this affects the vibration of the fixed atoms. The higher the metal's temperature, the more its atoms vibrate, and more would be the collisions, further slowing the drift velocity of the electrons. However, a higher current will cause more collisions as more electrons move faster through the metal structure. This makes the metal atoms vibrate more, effectively increasing the temperature as well. Got it?
Right.
Good. So here we can see in the table the different resistivity of the electrons and of the different materials as well. We saw in the previous table. We have the number of charge carriers now given in this table as well. And we previously saw the resistivity of various materials, good conductors, semiconductors, and some of them were insulators as well. It also showed us that how resistivity varies with temperature for metals and semiconductors. The resistivity of the semiconductors was seen to fall as the temperature rises, but the table A below shows how the density of the conduction electrons N in the transport equation change as well. You can see that at 20 degrees Celsius and at 50 degrees Celsius, how do they change? So you can see they are decreasing. When the temperature was increased, all of them decreased, but only germanium, no, but this also decreased as well. Got it?
Yeah.
So the negative temperature coefficients of resistivity for the semiconductors show that their resistivity falls as the temperature goes up. And the reason for this is the value of N in the transport equation as well. But that the number of conduction electrons are also decreasing at higher temperatures. Got it? So
Why are they decreasing?
a higher
Number of.
resistance wire heats up, becomes difficult, more number of collisions. When you increase temperature, what happens? They collide much faster, they gain energy,
Mhm.
right? So faster the collision, lesser the drift velocity, lesser would be the number density of the electrons as well flowing through the wire.
Okay, right.
A slight decrease in N for the metals at higher temperatures due to their thermal expansion. Rather than any change in the number of available conduction electrons, it is not as significant as the increase in collisions between metal atoms and the conduction electrons caused by the increased thermal vibrations as well. Got it? So,
Yep.
drift velocity is the slow overall movement of charges in a current. And what was the transport equation? I is equal to NAVQ, which I defines the electric current on fundamental basis, and it is the product of the charge carrier number, Q, the cross section area of conductor A, and the drift velocity of the charge carriers on the body. Q and small e is the same thing. Remember that. Don't get confused. And what is small q? It is also 1.6 into 10 to the power minus 19. Both of these are the symbols for this. Got it?
Right.
So, what do you understand by the term semiconductors?
Semiconductors, there were delocalized electrons that were able to conduct, typical, like it was like silicons and
Yeah.
other materials.
Semiconductors are generally solid materials that only have small number of delocalized electron. जो proper conductors होते हैं, those proper conductors have a lot of free delocalized electron. But semiconductor means semi or partially conductors. They have delocalized electron, but in a lesser number, which are free to conduct. A typical example is silicon, as you have just mentioned, one of the most common elements on Earth. But the proper permanent conductors include sodium, magnesium, different aluminium, and these metals. Semiconductor which have partial conductivity, silicon is a good example. They also have delocalized electron, but a little lesser than the conductors. Got it?
Right.
Free atoms have a series of discrete energy levels in which we can find their electrons depending on the energy the electrons have been received as well. If the electron receives enough energy, it will leave the atom altogether, leaving behind an ion. And in solid materials where there are many atoms close together, the allowed energy levels become much wider as well. So in the next lecture, you'll also see what is the difference between valence bands and conduction bands. So how will you describe conduction and how will you compare conductors? Let's say if I have to compare conductors with semiconductors, what's the difference between both of these?
Semiconductors is
Mhm.
only have a small number of d class electrons that are free to conduct, and while
Mhm.
a full
The only
or a
conductor. Yeah, conductor.
conductor have all delocalized electrons to be able to have electrons to move past much easily, freely,
Mhm.
and yeah, so they're much easier to conduct,
Mhm. Okay. All right.
while semiconductors are not.
Good. Let me. Okay.